We're going to continue working on 2.4, which was writing quadratic equations given a point and a vertex, or given a point and x-intercepts. So here's what we have. If we are given a vertex, we're going to use vertex form, solve for a, and then rewrite the equation with a, h, and k. And if we're given intercepts, we're going to use intercept form, solve for a, and rewrite the equation with a, p, and q, which are our intercepts. So, looking at this third example here, the graph shows the parabolic path of a performer who is shot out of a canyon where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. So we need to look. I am given the vertex and I'm given another ordered pair. If you're given the vertex and another ordered pair, you are using this form. So this will be my x and my y, and your vertex always tells you your h and your k. And I have my form y equals a times x minus h squared plus k. So we're going to plug in these four values where they're supposed to go here. So I'm replacing y with 15, because right here equals, we don't know a, that's what we need to solve. X is 0 minus h, which is 50, plus k, and k is 35. So I have 15 equals a times 0 minus 50 is negative 50 squared plus 35. 15 equals negative 50 squared is positive 2500. A plus 35. We will subtract 35 from each side. So we will have negative 20 equals 2500 A. Divide each side by 2500. Those zeros will cancel out, and these are both even, so you can divide 2 out of each of them. So reducing this fraction, we would have negative 1 over 125 equals A. So we found A. Our last step is to rewrite it in this formula using A, H, and K. We keep Y and we keep X. So Y equals negative 1 over 125 times X minus our H, which was 50, squared plus our K, which is 35. There's our equation. The next question says the performer lands in a net 90 feet from the canyon. So 90 feet from the canyon is, you can see it right there. We want to know what this height is. You can see if you trace it back, it looks like it's in between 20 and 25. But to figure out for sure, what will we do? We will plug 90 in for x. Y equals negative 1 over 125 times 90 minus 50 squared plus 35. So y equals negative 1 over 125 times 90 minus 50 is 40 squared plus 35. 40 squared is 1600, so we have y equals negative 1 over 125 times 1600 plus 35. And then we can multiply negative 1 over 125, and we will times that by 1600, and we get negative 12.8 plus our 35, and so our performer lands 22.2 feet in the net. The net is 22.2 feet above the ground. There we go. And you can see that makes sense on the graph. So another example, we've got a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. And you can see here already they are giving our intercepts, our x-intercepts, so we're going to be using intercept form, which is y equals a times x minus p times x minus q. And so this is going to be our x and our y. And p is 4, and q is 24. So we're going to plug those in to the right spot here. Our y is 9.6. We don't know our a, that's what we're solving for. X is 0 minus p, which is 4. And then we have x, which is 0, minus q, and q is 24. So we've got 9.6 equals a times 0 minus 4 is negative 4. 0 minus 24 is negative 24. So I have 9.6 equals a times, these two times together, 4 times 20 is 80, 4 times 14, or 4 is 16, so this is positive 96. To solve for a, divide by 96, we will have a equals 1/10. So our formula is y equals 1/10, because you replace a with what we just found, times x minus p, which is 4, times x minus q, which is 24. And what is the coldest temperature? So they are asking us to find this right here. It looks close to negative 10, but to be sure, we would need to plug in the axis of symmetry, because the axis of symmetry is where we'll always have our minimum or maximum. To find the axis of symmetry when it's intercept form, well, it's going to be in the middle of 4 and 24. So what you can do is you can add 4 and 24 and divide by 2, because that will find the middle number. So we have 28 divided by 2, which is 14. So the axis of symmetry happens at 14. That doesn't tell us our coldest temperature. What we need to do is plug in 14 to our equation. Y equals 1/10 times 14 minus 4 times 14 minus 24. So we have y equals 1/10 times 14 minus 4 is 10. 14 minus 24 is negative 10. And so we have 1/10 times 10 times negative 10 is negative 100. And 1/10 of negative 100 will be negative 10. Oh, so we were correct. Our coldest temperature is negative 10 degrees Celsius. Okay, so when you're writing equations, all you have to figure out is what they're giving you and plug them into the right equation. In this case, we did intercept form because they gave us the intercepts. Now, we can see from a graph whether the data shows linear or quadratic equations. So when the data has equally spaced inputs are our x values, you can analyze patterns in the difference of the outputs to determine what type of function can be used to model the data. So for instance, linear data has constant first differences. What that means is when I find the difference between 10 and 7, which 10 to 7 is minus 3, I can see that from 7 to 4 I have minus 3, 4 to 1, minus 3, and 1 to negative 2, minus 3. Since these are the first differences, meaning I only subtracted these once, then this is what we would call linear. And so if you are asked to write an equation for this, you would type the table into Desmos, and then you would hit that regression symbol, which was like this, and then make sure it says linear regression, which is what we did last chapter. But quadratic data, they have second differences, constant second differences. So you can see here our inputs are evenly spaced. Now we look at our outputs. From 9 to 4, we subtract 5. From 4 to 1, we subtract 3. From 1 to 0, we subtract 1. And then you can see here, this is a plus 1, plus 3, plus 5. So these are not all the same number. Let's do this again. From negative 5 to negative 3, we add 2. From negative 3 to negative 1, we add 2. Right here, add 2. 1 to 3, add 2. 3 to 5, add 2. This is what we mean by constant second differences, because these numbers, which is the second time we found the difference, are all the same. This is what we would call quadratic. So if you were asked to write an equation for this, you could type the table into Desmos. You will hit the regression button, and you want to make sure it says not linear. You have to change it to quadratic regression. And I'll show you an example of that. Okay. So on this back page, we have NASA can create a weightless environment by flying a plane in paths. The table shows heights h in feet of a plane t seconds after starting the flight path. From the data provided, describe the type of path taken by the plane. So you can see here on my inputs, I'm going up by 5 each time. So we can see how far did I go from 29,025, from 26,900. Well, we went 2,125. Then 30,600 minus 29025. We went 1575. Then 31,625 minus 30,600. We're at 1025. 32,100 minus 31,625 gives us 475. Almost there. 32,025 minus 32,100. We are at negative 75. And lastly, 31,400. Oh, that one's not right. I messed up on it. Nope, I'm good. Okay, let's see. 31,400 minus 32,025. Negative 625. So these are not all the same numbers, so we do it again. From 2125 to 1575, we went down 550. From 1575 to 1025, we are going down 550. And you'll see this pattern continue throughout the entire thing. Down 550, 475 to negative 75, down 550. And lastly, we went down 550. So this is what we would call quadratic. You are asked to describe the type of path taken by the plane. You would say quadratic. If you were asked to write an equation, this is where you would go to Desmos. So, opening Desmos. We open the graphing calculator. You are going to hit Add Table. If you want to make notes on your note packet while I'm doing this, go ahead. We're entering the data. 10, 15, 20, 25, 30, 35, 40. And then we enter the Y values. 26900, 29025, 30600, 31,625, 32,100, 32,025, 31,400. And then you hit this button right here that says Add Regression. You can't see any of our ordered pairs because we are so zoomed out. Okay, so that's what we have right there for ordered pairs. We're so zoomed out, but it will be quadratic, so we want to change it to quadratic regression. And this right here gives us our equation. So y equals negative 11x squared plus 700x plus 21,000. Okay. So the last one, you're going to do the same thing. Using Desmos, write a function that models the data. So you will type the table into Desmos. So first you hit the plus symbol, then you hit table, then enter the data. After that, you hit the regression button, and you want to make this a quadratic regression like we just did. So you change it to quadratic regression, and it will tell you the equation. So that's it for 2.4. I will answer questions when I come back.